In this example, we have to find an equation with roots that are given to us as being at 4 and at -3. So there's an equation, another way of thinking about this is there's an equation whose solution is going to be x equals 4 and x equals -3. Roots and solutions are the same thing. So the roots of this equation, or the solution to this equation, will be x equals 4 and x equals -3. We have to come up with what the equation might be. Now there isn't only one answer, there's actually an infinite number of answers here, but there's one particular one that's easiest for us to come up with. So if the roots are at x equals 4 and x equals -3, what we'll start off doing is we'll say x equals 4 and x equals -3. So that is the first step. If you look back at the steps in the notes, that's the first step, to set x equal to each of those. The second step is with each equation to move everything to the left hand side. So we'll move the 4 over here and the -3 over here. So in each of the equations we move everything to the left hand side of the equal sign. So that's going to become x minus 4. Remember, anything that crosses an equal sign changes sign. This is going to be x minus 3 comes across, becomes plus 3 equals 0. And the reason we change the sign is because they've crossed an equal sign. Okay. The third step is to take these two equations and multiply them together. So that's going to be x minus 4 times x plus 3 equals 0. And then use FOIL. So x by x is x squared, x by plus 3 is plus 3x, minus 4 by x is minus 4x, and minus 4 by plus 3 is minus 12 equals 0. If you use FOIL, that's what you'll come up with. Using FOIL very often, in cases like these, the two middle terms can be combined because they're like terms. So that's going to be x squared plus 3x minus 4x plus 3 minus 4 is different signs, so subtract. And that's going to be 1, but 4 was the biggest and it was minus, so it's minus 1x, which is minus x, minus 12 equals 0. And that's our work done. Okay, so that equation there has roots 4 and -3. Okay, now remember what I've tried to impress on you all along is that it's very important to justify what you do algebraically with a graphical picture of this. So we're going to do that right now. So I'm going to go to use WinPlot, which is something you can download for free. And here is WinPlot, graph set up for you already. And the equation that we came up with, I'm going to type it in, is x squared minus x minus 12. Okay, x squared minus x minus 12. And if we plot that graph, okay, what I want you to notice is where does this graph cross the x-axis? Remember, the solution to an equation is where it crosses the x-axis. It crosses at the points -3 and 4. Okay, it crosses at the points -3 and 4. So what I'm going to do, I'm going to take that, I'm just going to resize it a little bit, because I'm going to copy and paste it. Okay, lost it a little bit, but bring it back, there it is. And just post it into the work that we've just been doing here. So hopefully it'll fit here. And there you see, there's the graph. And the 4 and the -3 that we started with, those are the positions where the graph crosses the x-axis. That's how you know you're right. Okay, so let's go on with this a few minutes. One of the other things that we're going to look at here is there another way? Is there another equation? Well, let's just look at that. One way to do it, to find a second equation, okay, so that's the second equation with these roots. 4 and -3 can be found by simply changing all the signs in your answer. But it has to be all the signs. All the signs in the first equation. Okay? So that would be what would that be? So our first equation was x squared minus x minus 12. So we're going to try negative x squared plus x plus 12 equals 0. Okay, so we think this one should work as well. Now, let's try that one out. Let's try that one out in one plot and see, does it work? Does it have the same roots? Does it have the same solutions? Okay, so it's going to be, we're going to change this now. Let's go to the inventory. Actually, we'll put it in as a new equation. And we'll say negative x squared plus x and plus 12. Okay, we'll just make this 3 so it's a little bit thicker. And let's plot that. Okay, and now you can see what would happen. We've got the green line now. And the green line, the green curve is not a line, also cuts the x-axis at negative 3 and 4. So when we talk about solutions, roots, we're talking about where the graph crosses the x-axis. Both of these equations, the green one and the blue one, both cross the x-axis at negative 3 and 4. Okay, so let's just hide this first one. Just want you to be able to see all of it here. So let's just hide that so that we're only looking at the green one, and we'll copy and paste that one over as well. Okay. Hopefully we'll copy and paste it over. Okay, so there you go. Those are, if we can just position this properly, those are two equations. The blue one that we had previously and the green one that we have now. And both those equations have roots at 4 and negative 3. Thank you.